Hello and welcome to the second video on our Canvas module about climate change for A-level geography students. My name's Mary Gajan. I'm a professor of geography here at Swansea, and in this video we're going to talk about our climate now. In the first video we looked at climate changes in the past and how understanding the long-term evidence for the physical scientific basis for climate change is really important for geographers. In this video we're going to look at evidence for how our climate is changing in the present day. You will have seen graphs like this. Each of these dots tells us what the temperature was, the average temperature on the surface of the Earth in that year. And this single value comes from measurements from millions of thermometers from all around the world in different places. We use observations like this to see how the average temperature of the Earth has changed through the 20th and early 21st century. On the far right-hand side, you can see the prediction for the temperature change in 2020. And 2020 is likely to be one of the hottest years on record. What we are seeing now, if you want to do some additional research for homework, is that normally very hot years would also be associated with El Niño years, years in which the Pacific Ocean was in its anomalous warm phase. Now we are seeing very warm years in years in which there is not an additional El Niño warming associated. So that is the prediction for 2020. The other very important feature on this graph are the grey bars around the average line. And that tells us what the error estimate is on that. And it's really, really important as scientists that we consider what we call those error estimates, so the range of values that our observations fall within from different areas, to show us the average value with a sense of confidence around that, so that we can be confident about the changes that we're seeing in our climate. Across our planet, the average temperature change of the surface of the Earth is now above 1 degree Celsius, and in places it's above 1.5 degrees. Let's talk a little bit more about that. We're going to move on to thinking about how understanding climate change in the past and understanding climate change in the present is important for how we look at the predictions for how our climate is going to change in the future. The best tool that we have for developing predictions of climate change in the future come from large, complicated computer simulations called climate models. These models take everything that you're looking at in this picture, our atmosphere, our oceans, our biosphere, our lithosphere, ice, the cryosphere in parts of the Earth that are covered in ice, and turns them into computer simulations. You can think of it as like a grid, like a chessboard, where the surface of the Earth is divided into grid cells, each one representing the behavior and the conditions in a different part of our planet. You have grid cells in the atmosphere, grid cells that count as the surface of the Earth, grid cells that count as the cryosphere. And those model simulations are run over time to give us examples of how our climate might change. This is what the results of one of those big simulation studies involving lots and lots of different models run for a long, long time with multiple runs. They are sometimes called grand ensemble simulations. And this is an example of what those predictions might look like. And you can see the year 2000 is in the middle of the graph. Those models are used to run forwards in time, simulating how our climate might change in the future on the basis of how we understand the physical processes of climate to work on our planet. And how accurate they are likely to be in the future is assessed by running them back in time and then comparing them with our observations. We do that because the models that most closely fit our observations in the past are likely to be those which give us the most accurate predictions for the future. These are climate warming stripes developed at Reading University, and they're a really nice visual tool for us to look at those observations of climate change and see how temperature in specific places has warmed over time. These are the climate stripes for average global temperature change. But nobody actually experiences the average change in the temperature of the surface of the Earth. We experience the weather and climate where we live. This is what the climate warming stripes look like for the UK, and you can see that they become a little less obvious. They start to have years when things were a little bit warmer and things that were a little bit cooler. That is because as you zoom in on smaller scales, our climate has a chaotic element. There are some years which just happen to be warmer than average and some years that just happen to be cooler than average. That is why it is so very important that we think about the average global temperature of the surface of the Earth, because that's when we see the impact that we're having across how the temperature of the surface of the Earth is changing. But we also need to think about these changes that occur on smaller spatial scales that people experience. Let's look at what warming means for the places where we live. 1 degree of warming is something that we can probably learn to live with, mitigate and adapt to in richer parts of the world. But what if the sensitivity of our climate, that is how warm the surface of the Earth gets for a doubling of CO2 in the atmosphere, is actually closer to 5 degrees C? In a situation like that, the average climate of Cardiff will be similar to the climate of Paris. The average climate of Paris would be similar to that of Madrid, and the average climate experienced in Madrid would become similar to Cairo. That might sound very nice if you happen to live in Cardiff and think it would be nicer if it was a little bit warmer in the summer. But what does that mean when we start to think about climate extremes? The events such as heat waves and droughts, extreme rainfall events that affect our climate on a regular basis. Let's look at an example. In August 2003, there was an extreme heat wave that affected large parts of Europe. In that, there were significant excess deaths as a result of that extreme heat event, particularly in Paris and particularly around vulnerable groups. A single hospital in Paris reported more than 2,000 excess emergency admissions purely as a result of that climate emergency, as a result of that heat wave. So when we think about that time in the future when our climate may have changed significantly in the places where we live, that could be very, very serious to the impact that extreme climate events have on all of us. From climate models, we can expect that the global average temperature could be 3 or 4 degrees warmer by the end of the century. Let's look at what that means for the UK. If we manage to reduce emissions so that we make significant reductions in how much greenhouse gas enters the atmosphere, summer temperatures could only increase between 0.5 to 3 degrees C, with an average of about 1.5 degrees. But if we do not manage to do that, those temperature rises could be much, much higher. Think back to the very hot periods we had last summer. Perhaps you really enjoyed it, but did you know any younger people or older people who struggled to stay cool and who struggled to stay well in that situation? Climate extremes are problematic, particularly because they affect vulnerable communities. We know that our climate is changing and we know that it's our fault. One of the main reasons we know that when we look at periods of climate variability in the past is because the changes happening now are different to those changes. We are seeing the same changes almost everywhere on the planet is warmer now than it was 150 years ago. And we are seeing the changes taking place at a rate that is much, much faster than when natural climate variability occurred in the past. That means it is difficult for us to adapt. It is difficult for species and ecosystems to adapt. And the threat of dangerous climate change becomes really significant. Thanks for watching. And don't forget, if you're interested in climate change, to check out our brand new degree scheme in environmental science and the climate emergency.